Good morning, students. So today we are going to study about some of the problems in potentials. So let us consider the first problem. 2-point charge 5 into 10 to the power of minus 8 coulomb and minus 3 into 10 to the power of minus 8 coulombs are located 16 centimeter apart. So let us consider this one. So here, the one is the 5 coulomb, 5 into 10 to the power of minus 8 and minus 3 into 10 to the power of minus 8 coulombs are located 16 centimeter away from another. A is the one and B is then another charge. Now let us see what to find out here. At what point on the line joining the two charges is the electric potential is 0. So therefore we need to study about that. V is equal to the V1 plus what is that V2 is equal to this entire thing becomes a what here? 0. Now what is given? Given is the Q1 and also the Q2 is already given. Let the potential be 0 at a distance x. We will consider that particular distance. We require to find out that x from the charge Q1. So please observe this diagram here. So here is the 5 into 10 to the power of minus 8 coulomb is located at some distance, that is 16 centimeter. Minus 3 into 10 to the power of minus 8 coulomb is present. In between there is a 16 centimeter is there. So let us consider, here is the x is the some distance. So there is a P is located. I want to find out this x. We need to find out x. So 16 centimeter minus of x. So that is this distance we will get. From B we will get. From Q2 we will get. From Q1 we need to find out what is from Q1 what is the x. So therefore we have a one formula. V is equal to 1 over 4 pi epsilon naught Q by R. So this is the formula we have. This is called from first charge plus of what is that from the second charge. So let us simplify this. So V is always equal to 0. It is already mentioned here. The V is equal to 0. 1 over 4 pi epsilon naught Q1 divided by R1 plus Q2 divided by R2. Therefore, this is the quite common. So 1 over 4 pi epsilon naught if you take it over, that is becomes 0. So therefore what is left out here? Q1 divided by R1 is equal to minus of Q2 divided by R2. So substitute. What is the Q1? Q1 is 5 into 10 to the power of minus 8. X R1 is from here to here, this distance. From here to here, it is considered as what here? R1. So we have here X. That is equal to minus. This is minus 3 into 10 to the power of minus 8. So just substitute here. R2 is 16 minus of X. So therefore, simplify this one. Okay. So what we will get is X is equal to 0.1 meter. I am just converting this 16 centimeter into what here? Meter. So X is 0.1 meter. The potential is 0 at P at the distance x from the charge Q1. The X is equal to 0.1 meter. This is 0.1 meter. Let us go for the second problem. It is also the same time. Okay, two charges, 3 into 10 to the power of minus 8 coulomb and another one is minus 2 into 10 to the power of minus 8 coulomb, located 15 centimeter apart. From here to here it is 15 centimeter. I had converted to 0.15 meters. Centimeters converted to meter here. At what point the line joining the two charges is electric potential is 0. It's the same kind of problem what we have done in the first one. Okay. So here also it is the same thing. V is equal to, this is V. V is 0. The potential is 0. So therefore, 1 over 4 pi epsilon naught Q1 AP you already know that this distance. It's the same as R1. Okay, BP is nothing but from here to here, this distance is considered as what here the BP. So substitute the value. What is the 1 over 4 pi epsilon naught? 1 over 4 pi epsilon. You can take the common thing what we did in the first case. So what we did in the first case here, we have to take the common here. In the same manner, we can do here I have substituted everything. Okay, 9 into 10 to the power of 9. So Q1 is nothing but 3 into 10 to the power of minus 8 here, divided by x. X is the distance from here to here. We require to find out that particular point. So 1 over 4 pi epsilon naught is 9 into 10 to the power of 9. You already know that. 2 into 10 to the power of 8 is this one. Okay, so minus, in between there is a minus is there, so just minus is here. Okay, now you just simplify 9 into 10 to the power of this 2, 1, it goes that side, means it becomes plus. So therefore what is left out here? 3 divided by x, and another part is the 2 divided by what is that, 0.15 in minus of x is minus. So therefore on simplifying these things, you can able to find out what is the x. The x is equal to 0.45 divided by 5 you will get. So therefore it is equal to 0.09 meters. So it means that x, this distance, is equal to 0.09 meters. So this is the second problem. So let us go for the third problem. It is the same as that one, but the one point that P is taken in between, and in another case we have to taken away from this like this. Okay, I will explain this problem. I will just read out this problem like this. 2 point charges, 1 nano coulomb. Nano means what here? 10 to the power of minus 9 coulomb. So we have here 10 to the power of minus 9 coulomb and minus 4 nano coulomb. 4 nano coulomb, minus of 4 nano. Nano means 10 to the power of 9 coulomb it is. So the 1 meter apart, from here to here, the 1 meter apart it is there. In Yale, find the position along the join in the two charges at which the resultant potential is equal to what here? 0. So resultant potential is 0. So you already know that V1 plus V2 is nothing but a V. V is what is given here? 0. It is equal to 0. Okay, V1 plus V2 is equal. Potential of this side and potential of this side. On adding these two things, what we will get is the 0. That is the what the problem is asked here. Okay. So what is V1? 1 over 4 pi epsilon naught Q1 divided by x. You already know that. You can take x is what is it? This is the distance. Okay, A to what here? The P. Now another time the 1 minus x. Why I have considered 1 minus x? 1 meter here. From here to here 1 meter. Okay, from A to B. But this is x is this side. Okay, what is left out here? 1 minus of x. So this is the left out here. So that is 1 minus of x is equal to 0. Same type you substitute. Okay, in the last problem what we have substituted is the same thing. Okay, 9 into 10 to the power of 9. So 1 into 10 to the power of minus 9, that is nano coulomb. 9 into 10 to the power of 9. 4 into 10 to the power of minus. So here is minus is there, minus charge. So here. So just you simplify this one. So what you will get? Okay, on simplifying this, you will get what here? X is 1 by 5, that is equal to 0.2 meters. This distance is 0.2 meters. Now, let us consider the same problem. So, A is here, B is here. In this case, A is here, B is here. The P is in between. But P I will take here, this side. Okay, it means that position beyond the charges, beyond this particular charge. Then what happens here? Here it becomes a 1 minus x, but here it becomes a what here? 1 plus x. 1 plus x. X is the distance from here to here. So therefore 1 plus x. From here to here it is a 1. So 1 plus x it will become. Now what happens now? V1 plus V2 is equal to 0. You already know that potential is equal to 0. It is mentioned already here. Okay, resultant potential is 0. So therefore I consider the resultant potential V1 plus V2 is equal to 0. The position between the charges at point P, the V1 plus V2 is equal to what here? 0. Therefore, now I will going to substitute this one V1. What is V1 here? The 9 into 10 to the power of 9. 1 into 10 to the power of minus 9. Here is this is the charge. Okay. Minus of 9 into 10 to the power of 9. That is 1 over 4 pi epsilon naught value. So, and also the minus 4 into 10 to the power of minus 9. I have substituted here. This particular minus is here. That is equal to what is 0. X is the distance from here to here, and 1 plus x is the distance from here to here, the complete distance. Now let us simplify this one. So what you will get, the 9 into 10 to the power of 9 and this one, this get cancels. And then what you will get is the 1 divided by x, and also 10 to the power of minus 9 and 10 to the power of 9 is, that also cancels. So what you will get, 1 over x is equal to 4 divided by 1 plus x. And simplification of this particular thing, so what you will get is x is equal to 1 by 3. That is equal to 0.333 meters. So x is 0.333 meters. On adding this, 1 plus this much. So thank you for watching this.